So going over the chapter 12, mastery, just making sure that's in the video. So anyone want to see number one? The answer for it is supposed to be -3. Number 2, answer for that, -2. Number 3, anybody want to see it? Yeah. So number 3, first thing we do is distribute. We get 6x plus 10 minus 2x plus 2, all equal to 0. I can combine my variables and get 4x. I can combine my constants and get 12, still equal to 0. When I get that 12 over to the other side, it becomes a -12 because we subtracted 12 from both sides. I'm kind of moving fast because I want to give you guys time to work. When we divide on both sides, we then get x is equal to -3. Yep. 1 and 3 were both -3.
Can you do 4?
Yeah. The answer for 4, I'll tell you before I start, is 4.
Can you do 5? How about 6?
Some of you guys make these really complicated. You should realize, like, I don't try to make problems with really bad answers. I like terminating decimals, and I like integers. So if you get like some big crazy decimal, you might want to check, did I make a mistake? So when I distribute, I get 8x plus 4. Some people were forgetting the second part of their distribution. We always have to distribute first. So nothing happens with the 27. This becomes 6x minus 15. I can combine my constants on my right side before I go any further. So don't start manipulating both sides. Start by simplifying anything that you can. There's going to be a separate progressing mastery, even for you guys who were not finished, just because I want to be able to go over everything together. So 27 minus 15, those combine on my right side. Nothing happens on my left side. I get 12 plus 6x. I always like to take my variables to the side that is bigger currently. So 8x, I'll take 6x away from both sides. I now get 2x. If I take my constant over to my right side, I will subtract 4. I get 8. So then when I divide, I get x is equal to 4. You don't need more explanations than what I'm giving because I'm working fast. I'm assuming that you can figure out what I'm doing in between the steps. Five. When we get into these, this is where a lot of people had issues. When we have a situation that has one solution, that is like almost everything we've dealt with. You're going to have variable values, constant values, and the only thing that matters, okay, there's kind of two things that matter. Your variables on the left and right side cannot be the same. And to have one solution, you should be able to solve this. So whatever you plug in, you could solve the problem. So if I start plugging in A, my variables cancel out, and I realize, oh crap, I made a mistake. Same with B. If I plug in 9x, my variables would cancel each other out, and 4 would equal 0. That can't happen. If I plug in 4, 8 equals 9x. Well, what would I do to get the x by itself? I would divide by 9, and x would equal 8/9. Your answer is C. Notice also, this is one of the skills for when you have multiple choice tests. A has 9x. B is 9x. D turns into 9x. The only different one is C. So that would have been a good indicator of, oh, maybe I should try C. It's the only one different. In 6, we want it to have no solution. Who can remember what indicates no solution? Shahib? Okay, so the variables cancel out. Zach?
If it's something crazy like -9 equals 8, or something that isn't mathematically possible.
Yeah, something that's not true. I need a contradiction here is what we start to call it. So what can I plug in to make this never ever be able to be true? Shahib?
4x.
The 4x. Because if I plug in 4x here, no matter what I plug in for x, this cannot be true. Because 4x is shared on both sides. 3 is not equal to 12. We know that. Now, how do I get infinitely many solutions? What would, before I even move on to 7, what would I do to this that would make it have infinitely many solutions? Right?
Make the 12 a 3.
Make the 12 a 3, because if I have the exact same thing on both sides, then no matter what x is, it's equal. So when I come up here to number 7, and I look for infinitely many solutions, I just need the left and the right side to be exactly the same. So 6x. Because x plus 6x will make 7x, and no matter what you plug in, 7x and 7x. We switched 1a and 1b.
Okay.
We just had to do it for 8th grade.
Okay.
I was going to give him a second to look around. Wait, these aren't my classmates. So when you're looking for which one at 8 has only one solution, well look, 8x, 8x. So when they're the same, it's either infinite or no solutions, but it's definitely not 1. 5x, 5x, again, forget about it. We know it can't be 1. 3x and x, okay, that looks good. 2x, 2x. C is the only one whose variables are not equal on the left and right sides. When your variables are the same, it's either going to be no solution or infinitely many, depending on the constants. Guess I could have captured that. So when I look for how many solutions are possible, here I get 6x minus 18 equals 4x minus 16 plus 2x minus 2. So when I combine everything, my left side stays the same. My right side would become 6x minus 18 when the left and the right side are identical. Infinitely many. If they're identical, my variable doesn't matter. It can be whatever number I want. Pretty much everyone was okay on 10. 2x equals 5 tomato, and then you find out that it's 2,640. We want no solution. And if you're jotting notes on this, no solution, you want same variables, different constants. So again, as I look through here, 4x, 4x, okay, evaluate the constants, minus 2 plus 7, that'd give me 5. This would give me 5. My left and right side there are actually identical, so that would be infinitely many. If you want to jot notes to help you as you do a progressing to mastery. I'm going to come back to number 2. 8x minus 2, this would end up being 8x minus 2. So again, infinitely many. 7x minus 21, this is 1x. This, when I combine it, just becomes x plus 3. I see that I have different variables, different constants. That will have one solution. So number 2 is the only one that has no solution, because when I evaluate that, it becomes 3x plus 8 equal to 6x plus 4 minus 3x. I get 3x plus 8 equals 3x plus 4. Same variables, different constants, no solution. Consecutive integers. Guys, this should be easier than what some of you made it. If I know that they're going to be consecutive integers, and I know that it's the perimeter is going to have 2 times the length, and some of you actually forgot this, and 2 times the width. A couple of you tried to use just length plus width, and actually I think one of you did area accidentally. Zach?
Yeah, similarly.
Yeah, so if you think about the perimeter,
You just like
2 of this, 2 of that. Get rid of the 2. If I do half of the perimeter, that'll just be the length plus the width. Well, half the perimeter is 15. So what numbers right next to each other
8 and 7.
make 15? Yeah, 7 and 8. So my shorter side is 7. Now, the progressing to mastery, if this said what two consecutive integers would make a perimeter of let's say it said 42. Again, think about half the perimeter, 21, will equal two numbers that are right next to each other. So 10 and 11 would add up to be your 21. So whenever you're thinking about having to be right close to each other, I mean, you know that they're only one apart. So just kind of work your way up the, you can start with like 5 and 6, no, 6 and 7, no, 8, and like, you just keep moving. Questions on anything so far? I know I'm going quick. 13, some of you totally misunderstood this. When you go to the store, when you go to buy paint, because I didn't realize that I should have been very specific with this, you can only buy a gallon or a quart or like a 5-gallon bucket. But you cannot buy like a gallon and a half or a gallon and like, you cannot tell them what size you want. You either get a quart, a gallon, or 5 gallons. So gallons have a certain price and quarts have a different price. Bless you, that is not the same unit rate. 4 quarts, if you buy individual quarts, will cost more than a gallon. Kind of that whole American, if I buy more, I save money. Well, you spend more money, but you pay a cheaper unit price. So with equation 1, 2 gallons will equal $48. Most of us figured out, okay, the cost of a gallon is 24. Setup number 2 was 1 gallon, so just G, plus 3 quarts, which has to have a different variable. But since you already figured out the cost of the gallon, you know that this is actually 24 plus 3G equals 48. So what you can say, or sorry, not 3G, 3Q. 3Q is going to be 24, and you should get that the cost of a quart is $8. Then equation 3, check it. 6 quarts were the $48. If I do that division, I get 8. Does this make sense now, what I was trying to communicate? All 3 purchases were the same final price, the cost of a gallon and a quart. So I mean, I was kind of pretty clear. A gallon of paint costs G dollars. A quart of paint costs less than the price of a gallon. I think a couple of you just misunderstood, because when you did the gallon and 3 quarts, somebody had 1 3/4 equals the 48, like 1 3/4 some variable. That's, you cannot buy paint like that. You either buy whole gallons or just whole quarts. Yeah.
Yeah, okay.
16 I really like, by the way. The Smith family goes out to lunch and buys 3 kids' meals. Sorry, Ashton, you're still eating a kid's meal. And 2 adult platters for $8 each. Write and solve an equation, find out the cost of the kids' meal. This should have been simple. My constant was 16 for the 2 adult meals. Plus 3 kids' meals equals $31.75. We did not have a lot of issue with this. The kids' meal costs $5.25 when I solve. Subtract your 16 from both sides, divide by 3. Here, a little bit of fraction work. That's why it was one of the later problems, kind of more difficult. We get 3 halves x plus 6, because that'd be 12 over 2. Nothing happens with the 5 at first. 4/3 minus 1/3 x. I would need common denominators before I can combine my x values. So first thing I want to do is combine all my constants though. 5 minus 4/3, this is going to give me 3 2/3. Or I can make it improper to just jump right to there. So I'd have 11 thirds. Minus 1/3 x. It looks like thirds are the, I don't know, denominator of choice. So to make this have a common denominator, yeah?
Well, wouldn't the 1/3 be a negative? So wouldn't it make the 1/3 x positive?
Ah, yeah, good catch. This should be positive or plus. Because the negative 1/3 to the negative x. Good catch. I'm going to make this into 6. So triple it. 9/6x plus 6. I'm going to make this into 6 by doubling. So 2/6x. I can now combine them. I'm going to take my variables over here. 7/6x. I'm going to take my constants over here. So 11 thirds minus 6. Well, that's going to get complicated. So I'm going to make this in thirds too. 18 thirds is 6. So if I subtract that away, I get negative 7 thirds. Again, how do we deal with a coefficient? That's a fraction. No. Multiply the reciprocal. So times 7/6 times, times 6/7. I wrote it right. I said it wrong. The 7s cancel each other out. The 6 and the 3 work nicely together. X should just be -2. Again, very complicated problem, but the answer comes out nice. That's what I strive, like, I don't want the answers to come out to be some messy, terrible beast. Now 16, I think when we work it together, it'll make more sense. This was kind of like an exemplary option, but when I put exemplary option, some of you guys don't do it. So I just kind of left it as just like a challenging problem. One afternoon, Carly went to the mall and spent $4 on a frozen yogurt cone. She spent 1/4 of the remaining money on nail polish. She then let her friend borrow 1/3 of the money she had left, and then Carly has $8 remaining. So we don't know what she starts with, but building this is not as bad as you think. If you think about the money she has left equaling $8, the left side of my equation is going to have to be the money she has left. Well, in the beginning, she has X. She then spends $4 on frozen yogurt. So that happened. She then spent 1/4 of her remaining money on nail polish, but if she spends 1/4, how much does she have left? 3/4. So she'll have left 3/4 of whatever she had after the nail polish. And then when she gives her friend 1/3 of her money that's left, what does she keep? 2/3. And that's everything. So we can get rid of these fractions one at a time. Multiply by 3/2 and it'll disappear. So that will give me 8, 16, 24 divided by 2 is 12. I can then multiply because, well, I'll write it out so you guys can see it. Now I just have the 3/4 x minus 4. I can multiply by 4/3. 48 divided by 3, 16. Yeah. That's now just the x minus 4. How much money did she take to the mall? $20. Which is pretty standard for a day at the mall. If you got some absurd answer, I don't write absurd problems. I write problems that make sense. This was hard. You had to really evaluate what they give you. What they give you to be equal to is what she has left. So you got to think, what is remaining? How do I represent what is remaining? Yeah.
I got 40.
Okay. I mean, there was a mistake somewhere. Then you probably forgot this division by 2 or something like that. Yeah.
I did +1 or not.
Instead of the 2/3.
I just finished 13.
I've seen that solved other ways in previous years. Some kids get really creative. I think only like 2 of you got that problem. So if you got that problem, that was pretty awesome. Any other questions from the test? Anything you want to see again? I will post this on Schoology as well as the video. I will have your Progressing to Mastery hopefully by tomorrow. It was late last night when I got done grading these, so I just did not get that made. Last night was kind of funny. We had received email